Okay, this is exercise 6.1 Q2. I'm going to do some of the even numbered problems to give you a sense of how to use the derived rules. Start with number 2. So as you can see, number 2 has just the one premise, and then our conclusion is not H. So again, there's strategies for these derivations that the author puts in the textbook, and they're summarized at the end of chapter 6, I believe. But there's basically two ways to work. One is to look at your premise and apply whatever rules can be applied. So in this case, we have a conjunction, so we can apply the conjunction elimination rule. So we can get H conditional B by itself, and we can get not B by itself using the conjunction elimination rule. Okay, so that's one strategy, is to just apply whatever rules you can apply given the premises that you have. The other thing, though, is to always keep an eye on your conclusion, because you want to be headed in the right direction. So here we want to get not H, and if we look where does not H, or where does H occur, it's here as the antecedent of a conditional. So if we have H as antecedent, how do we get not H? Well, that's where the new rule that we learned in this chapter comes in, modus tollens. So we can derive not H directly using modus tollens rule on premises 2 and 3. So the modus tollens rule takes two inputs. It takes a conditional, like we have on line 2, and the negation of the consequent of that conditional. So since B is the consequent, we need also to get not B. So those are the inputs. So again, two inputs means you should always have two numbers after the rule. And the output we get is the negation of the antecedent. All right. So whenever you see a conclusion that's a negation, and the only place that occurs is as an antecedent, then maybe modus tollens is a rule to use. All right. So that's it for 2. We just needed to do conjunction elimination and then one modus tollens step. Okay, so number 4, you can see, has a couple premises. So one is a conditional J. 2 is just plain old not C. And 3 is J conditional C. And our conclusion is that conjunction. Okay, so there's two derived rules here we can use. Modus tollens, which we just went over, remember, takes a conditional as input and the negation of the consequent, and gives us the negation of the antecedent. So we can get that by MT23. The other derived rule that we can use here is the rule called hypothetical syllogism. Hypothetical syllogism takes as input two conditionals. And not just any two conditionals. It has to be two conditionals where the consequent of one conditional is the antecedent of another. So if you have if A then J and if J then C, we can validly derive if A then C by hypothetical syllogism of 1 and 3. So you can see the J's lined up, and they ultimately drop out, right? And your final conditional that you get as output has this as the antecedent and this is the consequent. So this is the hypothetical syllogism rule, is sort of sometimes it's called chain reasoning, right? Because you have this conditional connects to this one, J with J, like it's the link in the chain, connects to this one. And if you think of this kind of reasoning, it makes sense, right? If I say if Joe is taller than Sue and Sue is taller than John, then it follows that Joe is taller than John, right? So hypothetical syllogism works as when you have two conditionals and the consequent of one of the conditionals is the same as the antecedent of the other. Okay, so we still need to get to our conclusion. So we have not J, but we need to get not A. We can do that by doing another modus tollens step, because we have conditional here, negation of the consequent here, so that gives us the negation of the antecedent. So modus tollens, 5 is our conditional, 2 is the negation of the consequent. So 2, 5. Okay, so now we have our not J by itself and not A by itself, but we need to have them in a conjunction for our conclusion. So we have one more step to do, and that's to conjoin those two sentences. And that is, of course, conjunction introduction of 4 and 6. So we're introducing the conjunction. We got one of the conjuncts from line 4 and the other one from line 6. So conjunction introduction 4, 6. Okay, so that's number 4. Number 6. So we've got not A as a premise, B conditional A, B disjunction not C, and our conclusion is not C. Okay, so again, you can sort of do whatever rules apply, right? So you can see a modus tollens with premises 1 and 2. Premise 2 is a conditional, and premise 1 is the negation of the consequent. So modus tollens says we can get the negation of the antecedent. So MT1, 2. And now with that, we can see we have a disjunction elimination set up, because we've got a disjunction on line 3. We've got not B, the negation of one of the disjuncts on line 4. So we can get not C by disjunction elimination of 3 and 4. And that's our conclusion. So we're done. Okay, so number 8. We got this conditional and this conjunction, and we're trying to get not F. Okay, so again, on the strategy of do whatever rules you can do, we've got a conditional here. We can't do much with that, but we do have a conjunction here, and we can always break apart conjunctions using the conjunction elimination rule. So we can get E by itself, and we can get not G by itself using the conjunction elimination rule. Okay, so now let's look at the conditional in premise 1 again. Now we have the negation of the consequent, so we can get the negation of the antecedent. So not E and F by 1, modus tollens 1, 4. So we got modus tollens takes conditional, negation of the consequent, gives you the negation of the antecedent. Okay, so we're kind of stuck there. There's not really anything we can do here to get not F. All right. So when you get stuck like that, it's always a good idea to start thinking about the reductio rule. See, we're trying to get not F, and it doesn't feel like there's any way we can get it directly. So maybe we could try getting it indirectly. So we'll assume F for reductio. And now remember, once we make an assumption for reductio, we have to indent, right? We have to start a new scope line. And then we have to get a contradiction, something that has a form P and not P. Okay, so how can we do that? Well, we have E here, and now we have F. So we can put E and F together by conjunction introduction of 3 and 6. And we already have up above, oops, not E and F. So we get that by reiterating line 5, right? Remember, reiteration just repeats a premise that you have up above down below. So now we have our contradiction because we have E and F and we have the negation of E and F. So that's what you need to finish a reductio. You need a sentence and the negation of that sentence. That's the contradiction. So now we can go back to the original scope line and we can write not F, and we get that by negation introduction 6 through 8. So the reason it's negation introduction is because our assumption didn't have a negation and our conclusion does. So we introduced this negation right here. And the reason it's 6 through 8 is because line 6 was the line we made the assumption for reductio, and line 8 was where we finished the contradiction. So the subderivation was all the indented stuff. That's line 6 through 8. And remember, it's a dash or a hyphen there because it's that whole subderivation, not just 6 and 8, but 6, 7, and 8. Okay, so the last one here is number 10. We've got a conditional F and not a conditional F. We're trying to get F. Okay, so again, one strategy, do whatever you can do. Now, there's not really anything we can do here. We've got two conditionals. They don't line up, so we can't use hypothetical syllogism. Remember, for hypothetical syllogism, the consequent of one has to be the antecedent of the other, and that's not the case for either of these. So we can't do hypothetical syllogism. We can't do modus tollens because we don't have the negations of either of these consequents. Can't do conditional elimination because we don't have the antecedents. So we're kind of stuck. And if you're stuck, think reductio. All right. So if we want to do a reductio to get F, we assume the negation of that, not F for reductio. So again, we have to indent, and we always assume the negation of what we're trying to prove. Okay, so now we've got not F, we can do a modus tollens to get not A. So that's modus tollens 1, 3. So again, we have conditional, negation of the consequent, gives us negation of the antecedent. Now we've got not A, we can get F by conditional elimination of 2, 4. Right, so we've got on line 2, we've got a conditional. On line 4, we've got the antecedent. So conditional elimination tells us we can get the consequent as output. So now we just need to drop not F down. Reiteration of 3. There's our contradiction. So we're done with our subderivation. We come back to the original scope line here. And that's a negation elimination. It's elimination because we started with a negation here, but down here we don't have it anymore. So the negation got eliminated. And that's lines 3 through 6. Why? Because again, our assumption started here on line 3. And our contradiction ended on line 6. So 3-6. Okay, so hopefully that gives you some help with as far as applying some of these new derived rules. I'll be posting something for 6.2 with the substitution rules as well.